Hello students. In this video we're going to show a very simple property involving the gradient operator. So if we were to take the grad of f plus g, I'm simply going to show you that that would just be the grad of f plus the grad of g. And this follows from the fact that the gradient operator is defined as the recall, it would be in the first component of the vector, it'd be the gradient of the function. It'd be the derivative of the function with respect to x, comma, the derivative of the function with respect to y. Here it is in both notations, this angle bracket notation and the ij notation. I'm just going to show it for 2D vectors, not 3D. It follows similarly for three-dimensional vectors. So here we go. We take the gradient of something, and so that means we take the partial with respect to x of the something in the first component plus a comma, the partial with respect to y of the something in the second component. And then by linearity of the derivative d dx, I can distribute that operator into f plus g, and similarly for d dy, I can distribute it. And that's really the crux of the argument. That is why this step is actually why the gradient operator turns out to be a linear operator as well. So now remember, if you have a vector and you add the first two components, we can just reverse the process and think of that as this vector, this term comes from another vector and this term comes from another vector. And what I mean by that is this step right here. So you can just reverse engineer df dx comma df dy, that vector added to dg dx comma dg dy would look like this vector above. So you take the df dx plus dg dx on the top, df dy plus dg dy there on the bottom. So it works in either direction. And then of course this first term of the summand is the gradient of f plus the gradient of g, and we have just shown that the gradient of f plus g is equal to the gradient of f plus the gradient of g. So in general, if you had alpha and beta were real numbers, in fact this actually works for complex numbers as well, but I'll just stick with real numbers for simplicity. If you take the gradient of alpha f plus beta g, you can factor the alpha out of the gradient because you can factor a constant out of any of these partials, and you end up with alpha gradient f plus beta gradient g, and therefore we call the gradient operator a linear operator. All right, good luck.